All right, so some things that we want to talk about on there. First of all, make sure that we understand what mass actually is. All right, because we talked about this and it seemed like everybody had it down pretty good. But then sometimes when I go around and talk to groups, I think we're still having some kind of confusion on this. But really, what mass is, we're talking about the amount of particles in a substance, right? Okay, and then we talked about the law of conservation of mass or law of conservation of matter, same thing. Okay, this is important. This is a biggie. All right. So, with the law of conservation of matter basically means matter cannot be created or destroyed. If you remember that. And we wanted to be able to demonstrate in any models, like we have to do a model on Monday's quiz, that we understand this. Okay, so if I was doing a model, like they had the ice melting into a liquid, this is what we're talking about here. So I do a before and an after. So, whoa. So we have ice melting. We're going to have the before. We're going to have the after. So I kind of would do outlines of it. So maybe an ice cube like this. All right. And now, granted, I'm working with something here that I can do erasing and stuff like that. Otherwise, I might do pencil. And then the after, um, maybe I even draw a container around it or something. Okay. And then the after, I'm going to do oops, I just messed up. I can't erase it. And then the after, just to stay consistent with orange. I don't know why I picked orange. Okay. Something like this. Now, these are just outlines of the objects. This is not a good drawing for a model, is it? All right, so what's wrong with this? What do I need to add? Labels of things, particles, right? Number one thing that we got to make sure that we remember with this stuff, particles is dots. Okay? Now, I got to be thinking during this modeling process, what do I actually think happens to the number of particles? And I forget who I was talking to, but they were saying they were kind of confused as to what this meant. Ice melting. Um, I said if you just had the ice, so the frozen water, and compared the mass of that to the liquid water at the end, what would you expect the mass to be like? And then they said, oh, okay, I would expect it to be unchanged. And I think that makes sense. So if we start with, if I'm doing this model, first of all, I have outlines of the substances, but I'm going to put in dots to show that I understand there's particles within them. There's particles in everything. I could do dots all around it for air particles. I could even do dots in the beaker for beaker particles. But really all I'm concerned about here in my thinking is just the particles that are in the ice or the water. So maybe I do 5 dots like that. Okay? And here's why conservation of matter is important is because if I start with 5 dots in my model, I need to have 5 dots afterwards. If I just put 1 dot, well, that's showing me that the mass decreased by 4 particles for some reason. Where did the other 4 particles go? Okay, so where did the particles go? I have to draw them somewhere. But we're saying with our reasoning, our evidence, that these things, they're still there. They're just arranged differently now, and they're acting differently. This is just a physical change, just a change in phase or state. Okay, that's all it is. So there's some other things I did on here. Um, Different colors. This was something I noticed in the models as I went around. We did have people using different colors for different particles. But whenever we use the colors or whenever we have the particles like that, I should make a key. So blue dots. We just do the dots. We don't have to worry about the outline stuff. Blue dots. I could just put water or water particles. Okay? Cool. And the third thing is conservation of matter. Okay? Which means the amount of dots is important. And the reason why the amount of dots is important is whatever number we have at the beginning in the beginning model total, we should have those at the end as well. Okay?